Energy transfer. It's the stuff that moves us. Actually, I've been thinking about that cheesy line all day long, but there's some truth in that. We have three basic forms of energy transfer, guys, that you might want to know about, really that you need to know about. We have radiation, convection, and conduction. Now, these three types of energy transfers, they occur naturally within our universe, and they're all pretty easy to master, and I'm going to give you some concrete examples today. First amongst these is radiation, which is energy transfer from the sun, or it is given off in a chemical reaction. Usually when we talk about radiation, we talk about nuclear reactions inside of stars or missiles, but it also happens in any kind of chemical reaction that gives off heat. We also have convection, which is heat transfer through movement. Now, convection is a heat transfer that we primarily see in liquids and solids. And then conduction, which is heat transfer through contact. I feel the heat in my hands with the friction because there's conduction between the friction in my hands. Let's talk about conduction first. We're going backwards order with these. We said conduction is heat transfer through touch. The earth absorbs the heat from the radiant sun, but later passes that heat back through contact to the air. We also have an example here where a fire on a grill or a stove makes the frying pan hot. It absorbs the heat by being in direct contact with the source of heat. In this case, it's the fire. And then, of course, when we get in the shower, everybody loves a good hot shower, especially after a long, hard day's work. We feel nice and warm because our body comes in direct contact with that hot water, and that energy is transferred to our skin. Convection is heat transfer through movement. What actually happens is that as something warms up, a liquid or a solid, it expands, its volume expands. And the amount of stuff doesn't actually get lighter, but it takes up less space, so it's easier to displace by colder, denser items. For example, let's say that this was, air. We know from our study of weather that hot, humid air expands, and as it expands, it gets lighter, and then the colder air sinks in and pushes it up out of the way. Well, as it rises, cooling occurs, and as it cools, it sinks back down to be heated again. Okay? As objects heat, they expand and get lighter due to an increase in volume, and then as objects cool down, their density increases, making them heavier. Convection usually happens in a cycle, similar to this, whether it's liquid or whether it's a gas. This is my favorite one. Radiation. Radiation is energy transfer from the sun or chemical reactions, and really what happens is that inside of the sun or inside of other stars, all these little atoms and molecules are spinning around so fast that when they collide with each other, the explosion of energy that is released is passed off as radiation through space that later lands down on my tanned face. We're just going to do that with this one. What's more important is that usually in any process or major system that we see here on our planet, that there's definitely more than one heat process, energy transfer going on. For example, let's look at the water cycle. Now, I've drawn for you the most basic water cycle that there is. It has three parts. Evaporation, which we know is changing liquid to a gas. Condensation, which involves taking the gas, turning it back into a liquid, and then precipitating out. True, we're missing runoff, we're missing transpiration and groundwater saturation, but this will work for what we're trying to do. Radiation is directly involved in the rate of evaporation. The more energy we get from the sun, the more the water heats up, the more it evaporates. But once it evaporates, it's convection that takes all that water vapor in warm air and lifts it up into the sky so it can condense. If we didn't have convection, then all the clouds would be right at ground level and there really wouldn't be a whole lot of precipitation going on. So in this model, the water cycle really is driven by the energy from the sun that warms the water and causes it to change into a gas, but it's lifted up by that warm convective current passing the heat along to the upper atmosphere where it can cool down.